Hello. So, continuing with the module 5 concepts, we have already finished up with the basics regarding task and process, types of operating system. And in the last video, we've gone ahead and see some of the task scheduling techniques like the round robin. So, we finished up with the task scheduling techniques. So, the next concept that we have to go ahead and have a look at with regard to task communication. So here the task communication concept will be divided in two videos. I'll be talking about the task communication in two videos. So the part 1 I'll share about one of the mechanism, and in part 2 video I'll be sharing another two remaining mechanism that I used in task communication. So what is task communication basically? See, today's system is multitasking system wherein multiple tasks that are there in the systems are running concurrently, and each process may or may not have an interaction with each other. So there may be an interaction with many processes that are running together or running concurrently. Interaction may be needed or may not be needed. Now, based on the degree of interaction, the process has or the process can be classified as two different types of processes. One is called as a cooperating process, and the other one is called as a competing process. So, what exactly is competing or cooperating processes? We'll see. Starting with cooperating process. So, here in the cooperating process interaction model, what is going to happen is one of the process which for execution requires the input from another process. Now this requirement of an input or an information, we can say that exchanging of information has to happen between these processes, and that exchanging of information between these processes can happen. One is through sharing mode and the other one is through communication mode. So we have two different models in cooperating processes. We have two different models for exchanging of information, known as cooperation through sharing and cooperation through communication. Okay, what about the second type of process? Second type of process is known as competing process. So here these kind of processes are not going to share anything apart from or other than the system resources. So they are competing, multiple processes are competing for the share of system resources. Now when we talk about system resources, we are talking about the system resources like files, display, input output devices, etc. So here the sharing occurs only between the processes for the system resources. So thus such kind of processes are known as competing processes. So to conclude, what are the types of, we can say that cooperating processes are the one where sharing also occurs as well as communication also occurs, whereas in competing processes only sharing of system resources occurs. So these are different types of processes that can be classified based on the degree of interaction or degree of communication. So the whenever there is a communication between two processes, two or more processes or tasks. So here in this part, as you know, in this module we are using the word task and process interchangeably. So I may use process and task interchangeably. So here we say that the communication has to occur between the process or the task. So the mechanism through which this communication occurs is known as interprocess communication, also abbreviated as IPC. Okay, so here onwards, whenever I write IPC, that means it is the mechanism for the communication between two processes or tasks, known as interprocess communication. Okay. Now, in this module, we are going to study, there are many IPC mechanism, but we will be studying three important IPC mechanism: shared memory, message passing, and remote procedure call or RPC and sockets. So, in this video, I am sharing shared memory mechanism. In the next video, I'll be talking about message passing and remote procedure call RPC and sockets method or mechanism. So let us go ahead and see in detail what are these each mechanism. See, we can have the question wherein they have asked for 8 marks or 10 marks, they have asked about all the mechanism, explanation of all the mechanism of IPC, and then in that case you will have to write all these three mechanisms: shared memory, message passing, and remote procedure call. Or else there can be questions wherein each type of mechanism is asked as a separate question. Like they may ask you to write in more in details about the shared memory IPC mechanism, or they may ask you to write in more detail about message passing IPC mechanism. So each type of mechanism can also be asked as an individual question. So let's go ahead and see shared memory type of IPC mechanism. So here when we say the word is shared memory, that means the process communication occurs through a shared memory. So we have a physical memory available in an embedded system, but in some area of this physical memory has been allocated or reserved for the communication purpose, and this shared memory area or this memory area can also be called as a shared memory area, wherein a process can access this memory area for the communication purpose specifically. Now when I say communication purpose, that means a part of, now we are talking about shared memory. Now in this case, when I speak about shared memory, that means I am talking about a memory area which is reserved for communication. In the total physical memory what we have in the system, a small chunk of memory area has been reserved for the communication. That is called as shared memory in this case, right? So here if the communication has to occur, how it occurs? Now any process that wants to communicate the information to some other process, that process will write the information to be shared in the shared memory area, and all other processes which requires this information either to execute or to do the further processing, they will access or do a read operation from the same shared memory where the first process has written the information. So you can see the figure where we have seen that process 1 shared memory area and process 2. So I can consider that the process 1 has written the information that is required in the shared memory area, and process 2 requires this information, so it has performed a read operation from this shared memory area. So here in this shared memory also we have different mechanisms that can be used. It is, since it's a kernel dependent, so different kernels can use different mechanisms. So we will be talking about two different mechanisms that are used in shared memory. One is pipes and the other one is memory mapped object. So let us see what is pipes. Pipes mechanism is similar to what I have said. Same concept. Pipe is also a section of shared memory. Now here see how the things are. Now what happens here is we have a physical memory, a total physical memory that is available. So in that physical memory we have parted or we have reserved a small chunk of memory called a shared memory, and within that shared memory there is a section that has been reserved called as pipe. So pipe is a part of shared memory. Okay, so I have written it as pipe is a section of shared memory which is used for the process for communication. Okay, so here it follows a client and a server architecture wherein the process that has created the pipe is known as a pipe server, and the process that needs to access or connect to the pipe is known as pipe client. Information flow can be through the pipe or to the pipe. The information flow can be unidirectional or it can be bidirectional. So if you see the figure that has been shown above, so you'll see that it's a unidirectional flow, information flow kind of pipe, wherein process 1 wants to access a pipe. So what it does is it is conducting a write operation on the pipe, and the process 1 has done a write operation, whereas process 2 is having a read operation or it does a read operation. So here it's a unidirectional information flow. Now when I say bidirectional, the same figure you can have process 1 do a operation of read as well as write, whereas process 2 can also be read and write operation. So it can do read and write operation. Then we call this information flow as bidirectional information flow. Right now the figure shows unidirectional information flow. Okay, Now, the pipes can be two different types of pipes based on whether it is anonymous or whether it is named. So, an unnamed pipe is called as an anonymous pipe, wherein there is no name given. So, we don't know who has created it, or there's no name given to it. Then in that case, it follows only unidirectional information flow. So there can be only the pipe which has the process which has created the pipe can only write into that pipe, whereas all other processes that are connected to pipe can only read or do the read operation to this pipe. So it follows only unidirectional information flow. Whereas named pipe, wherein the pipe who the process is created, it has we know which process has created it, so it is named pipe, and it can have, the named pipe can have a unidirectional as well as bidirectional information flow. So this is all about pipe, a very small concept of pipe. And similarly, we have the second mechanism that is used in shared memory is memory mapped object. So this is also somewhat similar to the shared memory concept. Memory mapped object is adopted by certain RTOS. Not all RTOS have the same kind of or uses this mechanism. Certain RTOS uses this mechanism. So what is done is the shared block of the memory, there is a physical memory, and out of that physical memory that is allocated to the system, a small area has been allocated as a reserved memory, shared memory, or memory mapped object, or shared memory block. And this reserved shared memory block can be accessed by multiple processes. And for what these multiple processes are accessing, it is accessing for the communication purpose, that is process communication purpose or message exchanging purpose. Now here the memory that has been reserved, or here mapping object is created. The memory that is reserved as matching object is created. That means it has a virtual address space. So the processes can map this memory area to its virtual address space. So all if in case the process does a read or write operation to this memory address or to this virtual address, the read and write operation will be directed to that reserved memory. So here a virtual address plays a very important role. So in case if the process is doing a read operation or a write operation addressing this virtual address, then the information of read and write operation will be directed to that reserved memory in the physical total physical area. Okay, so here that virtual memory space is being used for doing the communication. It's as simple as that. So any process can read or do a write operation to that particular committed shared memory area. So that is what is memory mapped object kind of mechanism used for inter-process communication or inter-IPC mechanism. So this is all about shared memory. So in the next video I will be speaking about the message passing and also about the remote packet call. So here message passing is the concept of message passing is familiar to you because you have studied in operating system module 5 things about message passing. Some of the concepts are similar, like mailbox concept, and all those are repeated, so it will be easier for you to understand the message passing. Thank you very much.